video, we're going to be talking about Pearson's correlation coefficient. And the Pearson's correlation coefficient is a measure of the linear relationship between two variables. It measures between -1 and +1. So a -1 is a perfect negative correlation, and a +1 is a perfect positive correlation. And 0 indicates no linear relationship. So correlation is part of statistics, and it was part of statistics before it was part of machine learning, because statistics was around a long time before machine learning was around. But a lot of people might be familiar with correlation through their study of machine learning, but it's also part of statistics. So what we're going to do is we're going to do an example, do practice questions. And the practice question is going to be, the correlation between hours studied and exam score. And what we're going to do is we're going to write a program in Python to solve that problem, to answer that question. And so what we're going to do in order to answer that question is we're going to import 3 libraries, being number 1 is import numpy as np, which is the numeric library, and then we're going to, from scipy.stats, import Pearson's R. So Pearson's R is your Pearson's correlation coefficient, and stats is the statistical module in SciPy, and SciPy is Python's scientific library. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. And then we're going to set up our example data, which is going to be hours studied versus test scores. So hours studied is going to be a list of 1 to 8, and then the test scores is going to be a list of 40 to 95. And then after we've done that, we're going to calculate Pearson's correlation coefficient, comma, p-value equals Pearson R, brackets, hours studied, test score. And then so we're going to print the results. The results is going to be Pearson's correlation coefficient and then the p-value. So the Pearson's correlation coefficient is 0.99. So it's almost a point. It's almost 1, so that means it's almost a perfect positive correlation. The p-value is 0, and the positive correlation is as hours studied increases, test scores tend to increase. So the p-value is 0. So if the p-value is 0, that means that you would have to reject the null hypothesis. And the null hypothesis would say that there's no significant difference. But we know that's not true, because as the hours increase, the test scores tend to increase as well. But we'll go ahead and see what it says here. If correlation coefficient is greater than 0, it's a positive correlation. As hours increase, test scores tend to increase. If correlation coefficient is less than 0, it's a negative correlation. As hours increase, test scores tend to decrease. Else, print no correlation. Hours studied and test scores are not related. So what we're going to do is we're going to visualize the data. So plt.figure, brackets, fig size equals 6.4. we're going to create a scatter plot. So plt.scatter brackets hours studied, comma, test scores, comma, color equals blue, comma, label equals data points, and then plt.plot brackets np.unique brackets hours studied, comma, np.poly1d brackets np.polyfit brackets hours studied, comma, test scores, comma, 1, np.unique brackets hours studied, comma, color equals red, comma, label equals best fit line. And now we're going to add labels and a title. plt.title is hours studied versus test scores. plt.xlabel is hours studied. ylabel is test scores. You get a legend and then you get a grid. So we're going to show this scatter plot, and you can see the hours studied versus test scores. So your data points are in the blue dots, and then the red line is your best fit line. So you can see that as the hours studied increases, the test scores tend to increase as well, which is why you got a 0.99 correlation coefficient. So that concludes this video. The next video, we're going to be talking about the Spearman's rank correlation, which is a different type of correlation coefficient, and I hope that you decide to watch it.